So in the last tutorial, I showed you how to create your own integration method and how to use that on one of our samples. In this tutorial, I'm going to show you just a quick way to use that method that you created to analyze different samples, as well as go in and actually change your integration method and edit it if you need to change it based on changes in instrumental parameters coming from the OCEC instrument. So to start, we will begin by, in the previous tutorial, we looked at wood smoke sample 06, and this one I'm going to go to 05 and just show you a quick method. So if we don't want to create a graph and just to integrate this data quickly, we can highlight FID signal 1, and we can actually go analysis, peak and baseline, peak analyzer, and the previously created method I created last tutorial we can see is pyroprobe_AC. So I'm going to click that right away. And what that's going to do is actually it's going to integrate that FID1 signal based on the parameters we created last tutorial. So we can see here the area for the first range is about 800,000, and the area for the second range, which was the calibration area, is about 290,000. And we can see once again that it knows that we want to integrate from 1 second to 775, and then from 776 to 885, which is the calibration peak area once again. And like before, I will rename this quickly here just so that we know it's for 05 wood smoke integration. Just so that when we are looking at our sample sheets, we can kind of just go back and forth and know which one we're looking at. So what I'm going to show you next is if we actually want to go in and change those ranges in our integration method. So we'll go back to our wood smoke sample 06, and then we'll create once again another graph of this sample, and then we're going to go in back into analysis, peak and baseline, peak analyzer, and then we'll open our dialog once again. And then instead of going and creating our own method, we can actually go up here at the top where we see dialog theme and click our right facing arrow, and we can open up the pyroprobe_AC, which we created last tutorial. So I'm going to open up that, and we can go through, click next, going through the first things like we did last time, and we're going to actually see that our old data that where we changed our number of peaks to 2, as well as number of ranges to integrate to 2, so we can see that. And if I move this box, the peak analyzer box, we can see that we have everything set up nice here already. So say we want to split this up into 3 sections instead of 2, so we can look at maybe our our total organic carbon and maybe our total elemental, and also keep that calibration peak area. So the way we can do that is we'll go back one step, and instead of the number of peaks we want to integrate, we'll change this to 3. We're going to go click find here, so that changed this to a 3. And once again, it's going to pick the 3 highest peaks on this graph, which will create a little bit of a problem if we don't fix it. So we have to go into peaks info and switch our peak center. In this case, we'll go about 130. Click OK. So, and we can see that kind of lines up right to the top of this peak, and then we can actually click snap to spectrum, which will make that 130 peak go right to the top of this area. And the reason we need to do this, because if we leave it our peak center over here, it's actually going to integrate 2 peaks in this area, and we won't get a peak integration over here in our organic carbon area. So that's why we switched to this peak here, this high peak in the organic carbon section. So next, after we switch the peak info, we can click next once again, and then we can move this peak analyzer over a bit, and then arrange how we want to have our range set up for this one. So in this case, we'll say we're going to start at 1 second, and then we'll go to 500. Hear that? Go to 500 in this case. We'll say just assume that that's all of our organic in this case. We can scale this to go to 501 to 775, which is the start of our cal phase. And then we'll scale this from 776 to 885, just like we had in the last method that we created. So we're going to click OK. And in this case, we will save this once again, and we'll leave it as pyroprobe underscore AC. We'll save over that. So now we're actually integrating 3 areas. We'll click save, and then we'll click finish once again. And then we can see the ranges from here. So we're starting range from here to 1 to 500. We can see our high peak here at 130. Same with this range here. And then once again, our cal peak area range. So if we minimize our graph, we go back and we can see integration underscore result 1, which we can rename, but I won't in this case. And we can see that there are 3 areas that are integrated instead of the 2. And looking over at beginning X, we can see it's 1 to 500 seconds, 501 to 775 seconds, and 776 to 885, just as we set up in our peak analysis integration mode. Just to make sure and double check that our method that we just created and edited still works, we can go back here and check it on wood smoke sample 05. So we can highlight and do the short method like I showed you before, peak and baseline peak analyzer. I'll click this because it's our newly saved 3 range area. We'll click this, and we should see integration results in 3 areas, which we do. So we can see our 3 area ranges, and once again looking over beginning X, ending X is what we just set it as in our new integration method. So overall in this tutorial I showed you how to create a method and then edit that method that you previously created. So this comes in handy when you want to switch a method that you already have in case temperature or instrumental parameters are changing. So it's a really useful method to be able to do this on Origin. And if you want to go into further detail and really split up your temperature fractions for your organic and elemental carbon, I'll just pop up this graph. You can put that back. If you want to really split up these fractions like you see here and get the actual peak areas for different temperature fractions, you can go into the analysis peak and baseline mode analyzer and change to as many ranges as you want. So you could have 13, 15, depending on how many temperature programs you do have in your method. So overall, this is a great Origin's a great tool to be able to split these fractions apart and determine the peak areas in different organic, elemental, and lastly your calibration areas.